So just to introduce myself, I don't know if anyone's actually heard of Tangent Technology. It's a Toronto and Winnipeg-based company. It's not a Sony or a DreamWorks, but I think you'll probably hear a little bit more about us moving along. I don't know. We've just completed a movie called Next Gen that released on Netflix. I don't know if anyone's seen that. You have? That's awesome. And we'll play a little bit of a clip from that. The story's not about me specifically, but I'll sort of tell you a little bit about my background. I started my career working at a company called Side Effects years ago, sort of teething my career on 3D, and I loved it. And like a lot of people in this industry, we kind of fell into the production space, and I'm the same kind of person. Like I just came into the production space in a circuitous route sort of thing. I did web development for 3D. I did film and TV projects after that. And one of those projects, one of the companies was DKP. Stephen Oliver and I go back a long way. We met back then too. And that's where I actually met one of the owners of the company of Tangent Animation. And we didn't actually connect till years later, probably about 10 years later. And he was talking to me about this new project. And I knew what Tangent was actually doing probably about 3 years before that. And I thought they were a little bit nuts, because their story was that they were using open source software and we're using Blender. They were using Blender. And at the time, I'm used to dealing with commercial software all the time. The highest end hardware, big studios. And I kind of thought, there's no way they can make this work. I just thought at the time. Jeff sort of opened my eyes a little bit when I was talking to him, and I go, okay, I'm going to keep an open mind, and I'm going to come over and see how it works. The truth of the matter is you can actually do it. And we proved it, and we'll see some clips there. It's not always an easy path, I don't think. We had issues with Blender, and we'll get into a little bit about that and how we dealt with those issues and how ultimately Amazon sort of helped us sort of overcome some of those hurdles. It can be done. You just have to keep an open mind, and everyone has to get on board. I'll leave it at that, and I'll just start into the slides. So who we are, we're an independent animation studio. We have 2 offices, Winnipeg and Toronto. That actually presents its own challenges sometimes because we still have to keep the data in sync. They do a lot of, essentially we break up the production such that they're doing sort of modeling and surfacing over there, and all of our render resources over in that studio. Toronto has the bulk of the staff. I think we were on this project probably more along the lines of about 120 people in Toronto, so animation, rigging, shot filing, a lot of the shot filing, and some lighting. We did the lighting here and then sent it over to Winnipeg to render. Tangent's actually delivered 2 feature films. The first one was Aussie, which was in 2016. They were also using Blender, but they weren't using all the features of Blender. So the budget was lower. They did render cheats. And if you look at Next Gen, which was released in 2018, there's a massive difference in visual quality. So if you sort of look on the web and you look at Aussie and then you compare the two, there's really no comparison. We're actually, I'll just touch on this quickly. We're actually all under sort of one roof, but we're broken up into sort of 3 different divisions: animation, technology, and labs. Technology is obviously delivering asset management, production management, and pipeline solutions to the animation side, but we're sort of there's a sort of a fuzzy gray area we're trying to keep a little bit separate. Right now we have another major production underway, and we're growing pretty quickly. So we've actually just moved spaces, or we're going to move spaces next month, so we're pretty excited about that. So Next Gen, we'll show you a clip after this, but there are, a bunch of challenges here. The first thing is we were required to render essentially 3 different versions of this movie. So we had stereo mono, we had stereo English stereo, Mandarin stereo, and just the regular mono version. So as far as frames go, like mono versions is kind of like 5 times the rendering. So we had a lot of it to do. It's rendered at DCI 2K. The directors were not constrained at all. Everything was moving camera. There's no held shots. Another interesting thing is that we actually rendered in camera. We didn't do a lot of comp tricks. We're using a path tracer, Cycles, which comes with Blender. So that was also challenging. I'm used to coming from a background where we do a lot of in-shot comping, like we break apart layers, pull them back together, so comp lighting. We didn't do any of that, or very, very little of it. Lots of crowds, lots of visual effects. I think you'll see some examples of that. I'll talk through a little bit about it. Some of the shots had 20,000 characters in it, and it was challenging, but we got through it. As I mentioned before, we use Blender, which is obviously open source. I'm sure a lot of you have heard of Blender. People question whether or not we were actually using Blender on the project. We did almost all the way through. There were a couple of places where we actually had to insert other packages like Houdini to deal with effects, but almost all of it was Blender. All of it was rendered in cycles, and I can touch a little bit on some of that. Tangent from the beginning has taken kind of an interesting approach to the way we're dealing with open source software. We had to actually develop a lot of functionality for the render for cycles to get it to production quality rendering. There were a lot of features that you would take for granted in something like RenderMan or Arnold that just actually didn't exist in Blender. So we took the approach of, well, we're not paying for the software, so we're going to invest in people instead and start just building out a render that actually we can use. So I think at the end we probably spent about, I'd say about around $500,000 over the course of production just on staff. We also fund a couple of people at the actual foundation as well to work on things. The interesting tack that we're taking, though, is that we're actually contributing back to the open source. So everything that we're doing, we're just putting right back into Blender. So anything that they're taking, you guys will have as well. So all the render optimizations, we're doing like tile caching, all the sampling optimizations, everything that you need to actually render a film is like in a reasonable amount of time is going back in there. So that's pretty cool. We can start just jumping in the trailer so you can, if you haven't seen the movie, you can kind of get an idea of what it looks like. And it's a little weird because I can't hear what's going on, so hopefully this comes out. No sound? One sec. Move on. What's that?
This close somehow. I don't know. Let me just.
Yeah. Okay. Well, we don't have sound. That's okay. We'll just move on. Or not. So, sorry about the sound. We'll just move on. So a little bit of background about NextGen. It was originally created by Baozhou. It's a social media company in China. So Tangent, in this case, acted sort of as a service provider for the movie. So we did all the work here in Canada between the two studios. The timeline was about 2 years, maybe a little longer. And their strategy was to actually build a film that actually appealed to both Chinese and Western audiences, which I think is a pretty difficult thing. The cultural sensibilities are quite different, but I think they succeeded. I'm not sure I mentioned this. This was released on Netflix in September of last year, and then the Chinese distribution, the Chinese release worldwide, is happening next month sometime, I think. Okay. So the delivery specs, they're pretty standard. So it's DCI 2K 2048 by 1080. The 2D Netflix delivery, so there wasn't a stereo delivery for Netflix, obviously, was about 140 frames worth. Then we had to do a stereo English version of that, which is about double, obviously, for the left and right eye. An interesting note is we actually had to re-render the left and right eye, almost all of it, I think. So it wasn't quite the 280,000 frames, but it was pretty close. Then we actually had to do a stereo Mandarin conversion, and the reason that we didn't have to re-render everything is that not everything in the show was talking, so we just skipped past that. So total of 330,000 frames, and if we look at the next slide, and I'll just kind of walk through it, our average render time was 4 hours per frame. And we can go through some of the optimizations. Some of the renders actually were like just obscenely long. And we spent a lot of time on cycles actually getting the render times to be predictable. Like some of the render times were actually 8 hours, 4 hours. We couldn't tell. So we actually really got it down to an average of probably 3.7 hours at the end of the day. Obviously, it doesn't always come out right the first time. So we factor in 1.5 times that. Ignore the numbers because these won't make entire sense. But so we factored in 1.5 times render just for mistakes, and then nobody uses the render farm at full capacity. Like no one does, unless you have multiple projects and you have the farm running 24/7. In our case, we're probably using our internal render resources probably about 70% of the time, maybe 80, but we never really got up there. And if you're in production, you'll get to a point where the actual rendering curve goes something like flat and then straight up, basically, because the times get compressed and the schedules get compressed, and it's lighting that usually bears the brunt. And you'll see that coming up. Internally, we actually had a render farm in Winnipeg. Our servers were 16-core HP blades with 128 gigs of RAM in them, and then we had workstations on the floor as well, which we used. They're dual boot. I should note that internally on the floor we're actually using Windows, which might be strange for some people, and everything else is Linux. So all the rendering resources were Linux. So if you look at the numbers here, we had 550 blades, and if we used everything at full utilization times 24 hours, we have maximum available to us 13,000 hours a day, roughly. Workstations are 2,100 a day because people are actually doing work. And this is in the best case scenario, we'd have about 15,000 hours to work with. It's never the best case, so we had to start looking ahead. So we found out early on when we started lighting, we started doing projections. We saw pretty quickly that we were going to need more render resources that we had internally. And as I mentioned, even in our case, our schedules were somewhat compressed. So if you look just sort of at the months line there, you can see at one point after month 5, it's like, oh, we just need a whole bunch of rendering resources. And it wasn't quite like that, but it was pretty close. So we knew ahead of time, probably 2 or 3 months, that we had to come up with another solution. And the obvious solution for us was the cloud. There was no way we were going to be able to build out a server farm with 3,000 nodes in a couple of months. Just ordering that hardware takes months. And just the capital cost would be prohibitive. So at the end, sort of at month 6, and this is pretty much what happened, we spent the last 36 days spooling up about 3,000 EC2 instances on Amazon and just rendering the whole movie. And it worked out great. So we can talk a little bit about why we chose AWS and what the benefits were. First was Deadline. We have a good relationship with Thinkbox and Deadline. We were already using Deadline internally on our own internal render farm, and probably about a year and a half, 2 years before we started working on the project, or just before we got to this stage, AWS acquired Thinkbox, and they already had an Amazon cloud solution, so that kind of made sense for us. The other really big issue, and I'll get into this a little bit later, is just the massive selection of resources on AWS. So our hardware is fixed. We had, our nodes were maxed out at 128 gig. They were 16-core hyper-threaded processors. We couldn't expand what we already had. We didn't have the server space. We didn't have the power to do it. And Amazon does. Like, they have the infrastructure. You pick the right data center, and you have a lot to choose from. And we really, really appreciated the fact that we could do it. The mere fact that we could, at a whim, spawn up 3,000, 5,000 nodes on it every night gives us so much flexibility. And it really ended up being the difference between completing the show and being late. And we literally did not have a choice. We could not be late on this project. So I've run into cases in my past where we delivered late because we couldn't render. And I'm going to suggest that if you don't have a rendering solution in the cloud now, you probably should start thinking about it. It always comes up, I find. You can tell how much you're actually spending as well. So the total cost of ownership is pretty obvious. You know how much power costs, you know how much the EC2 instances cost, S3 costs. It's already built into one bundle. You get a bill, it's really easy to see what's going on. If you have your own internal infrastructure, total cost of ownership is a little bit harder to gauge, and it's harder to bill against, I find, for productions. Amazon makes it just simple. You just get a bill, and depending on how you want to charge it or fold it into the cost of production, you have a lot of flexibility there. The other thing is just the creatives. They can make changes till the last minute, and you know how creatives are. They want to keep going. And if, we're not burdened by hardware limitations anymore, if it's just a cost thing now. So if the director wants to spend the money and make changes, a week before, and it's going to take a long time to render, it's not a problem. You just spool up more instances, and it's just a cost thing at that point. And we had that case too. It's every production I've been on, the directors want to make changes at the last minute, and here it's no different. So yeah, if we really start going to the cost considerations, for us, we would have had to build out a 3,000 machine farm. We picked on Amazon, a mixture of render nodes that were 128 gig, believe it or not, 256 gig, and some actual shots required 512 gig, and we did not have those resources. And I see some eyes like going, what? And I'll explain why that is in a second, and that's part of Blender and cycles, and there are technical issues that we had to address. When we actually hit those shots, we didn't have time to fix them, either artistically or technically. We had no choice, and the only thing that saved us in this case was actually Amazon. So we literally could just say, hey, we want a large EC2 instance with 512 gigs of RAM. It's not necessarily the cheapest solution, but it did get the job done. And like I said before, there's no way we could build a 3,000 machine render farm. And even if we did, we would have used it for a month, and then all that hardware is just sitting around, and that's just a huge waste. It's okay for bigger shops because they usually have 4 productions running simultaneously in different sort of stages of production, so they're using the render farm probably 24/7. And the reality is, I think for every studio they need some internal infrastructure because they're just using, they do test renders, they do check passes, play blast, whatever it is. So you need some render farm, but once you start getting to lighting, that's, I think, a big difference. So at Tangent, we're actually sort of downsizing our render farm cluster in Winnipeg, and we're moving our infrastructure entirely to the cloud. And later on, you'll probably see more talk about that, but we're kind of going all in. We'll always have some internal infrastructure, but almost all of our stuff's going to the cloud. We're using open source software as well, Blender, so we don't actually have to deal with licensing issues. So if you're using other commercial software, a lot of the times they have restrictions on whether or not you can install it on cloud hardware. Blender kind of just freezes up from that. But Blender itself, we'll go into some shots where we actually had problems and why they were problems. The reason that Blender is awesome in this case is that we have access to the complete source code. And even if you buy commercial software, there's always bugs in it, and to get those bugs fixed takes sometimes months, sometimes years, or you have to pay a lot of money to get it fixed. So Blender is a different story. Not a lot of people use Blender in North America, and I believe we're the only studio that's done a feature film with Blender. So if anyone has questions about that, because I was skeptical about the whole thing before, you can always contact us afterwards. Unfortunately, we don't have sound, but I'm going to explain why we had some technical issues and why we had to use massive amounts of RAM. This is one of the shots. And I'm just going to play this quickly, even without sound. It's pretty effects heavy. So I stop, play it again. There's a lot of volumetrics, smoke, fire, all rendered in camera. So one of the things we found while we're trying to render some of these shots, especially with volumes, is just the way Blender handles volumes and domains in the first place. So we built an OpenVDB pipeline in Blender, and what was happening originally is we imported the OpenVDB volumes directly into Blender's internal data structure. The problem with Blender's internal data structure is that the domains sampled evenly. So it's not a sparse VDB volume at all. So when you get this number of volumes, the subdivisions are just crazy, and our memory spikes. And there were cases where it literally would not fit into 512 gigs of RAM. We actually fixed the problem. We have a solution for that now, but at the time we didn't have the solution, and we had, something like a week. We just had to get it done. In this particular case, I don't know what we would have done. The only way we could have fixed the problem is to break apart the shot and recomp it again. And honestly, artist time is way more expensive than machine time. So it's the path of least resistance is just to render it on like giant machines. And it worked out great. And we had not a huge amount of shots like that, but I'd say, there's 4 or 5 maybe. The other class of nodes were probably 256 gig. We had a lot of those too. And I'll explain why. The other idiosyncrasy of Blender, and we fixed this problem as well, by the way, is that when they load texture maps, they're loading the whole texture map in RAM all up. It's all front loaded. It's not tile cached at all. So if you have a bunch of 4K or 8K maps, they're all being loaded into memory. And if you watch the movie, there's tons of textures, there's tons of animation going on. That was all being loaded to RAM. So we actually, more often than not, I'd say about 30 to 40% of the time had to render on 256 gig nodes. So for people who come from an RIS or Arnold background, maybe mental rate, that does sound a bit crazy because it shouldn't require that. And it doesn't now. This is stuff we're patching back into the main cycles branch, so people actually have access to this as well. So these shots are not as memory intensive now, like moving forward. Another example is this, which seems a bit nuts, and you guys might be a little bit surprised, but I'll play this through. This is an underground water shot. This particular shot, there's about 100 frames in this sequence, or this shot, which I think took about 2 to 3 days to render. And we weren't quite sure why at the time. Part of it was an artistic problem with shading and just sampling. Part of it was actually just the water itself. So it's a really, really big simulation that we were importing into Blender. So what we did, we were under a render crunch period, and this is actually one of our last shots that we had to do. What we wanted to do is just sort of backburn this somewhere and just let it run because we just didn't have time to fix it. So we had 2 options. One, we could take 100 nodes from our internal render farm and use it, or we could just send it to Amazon and just let it cook and not worry about it, which is actually what we ended up doing. I'll just play that again. So it's heavily reflective and refractive, and that was a lot of the problem. They're trying to get the noise down, and unfortunately, it just ended up just being really expensive to render. So this is the only shot that's like that in the whole movie. So that's pretty much it. I'm just going to note that when I talk about fixing technical problems, we actually are hiring people either externally. We have one or two people remotely that are working with us as well. One's in Germany, one's in Saskatchewan actually. So they're doing remote work on Cycles and Blender. And as I said, we've ramped up our technical staff as well for the next production. So we're pushing more features in. Hopefully we'll make Cycles better. And it's all, if anyone's familiar with 2.8, the newest release is 2.8. That's the one we're moving to, and we're going to be fixing a lot of problems in there hopefully as well. We're actively talking with the Blender Foundation to work with them as well. So we're pretty excited about that relationship. And we got to say, like, thanks to Thinkbox and Amazon, because if you guys weren't here, I don't think we would have actually made our deadline. I think that's it for me. So I don't know. It's hard to ask questions in this venue, I think. But if you're curious about anything like our Amazon experience, feel free.